What do we study in this unit? Last unit was rectangle, rhombus, two-dimensional figures. Now we're going to study a three-dimensional figure, which we call a polyhedron. Those are the three-dimensional figures. There are three parts to a polyhedron. And by the way, a polyhedron, a cube. Anybody seen a pyramid before? How about a cylinder? Cone? Sphere? Those are all types of polyhedrons. Right, three-dimensional closed figures. There's three parts to every polyhedron I need you to be familiar with. All the polyhedrons come with a face, or faces. Okay, faces. Think of it as, I don't want to call them the sides, because there technically are no sides. They're called faces. So one face on this example here I give you, time's up. D, C, G, H. That's a face. Okay? Everyone see what I mean by a face? Which brings me to, everyone's good to go for Monday? We're all set for Monday? Deposit them as you come in. We're all good? Okay. We usually don't have a problem in this class, so no issues. All right. What connects the faces together? An edge. All right. All these polyhedrons come with an edge. So, for example, edge AB. In this diagram here, they connect the faces. And then finally, what are the edges connected to? Vertices. We've heard those all year long. Vertices. So I'm just going to pick vertice H. It's a point, kind of like a point. So those are the three things I need you to be aware of as far as polyhedrons go. Faces, edges, vertices. All right, the three examples up there. Can you find how many there are? Ooh, can we find how many there are? So example one here. First, I want to give names to everything. This is a cube. Cube. All right, number one is a cube. How many faces are on this cube? Faces. We have 6 faces. Edges. How many edges? And I always get worried because people forget an edge or they count one twice. Be careful. How many edges up here? And this is, I don't want to call numbers here yet. Griff, what do you got? 12. 12 edges, yep. And then please count how many vertices for me. How many vertices are we working with? Matt? 8 vertices, yes, 8. Well, we okay? Anybody know what the figure in the polyhedron in number 2 is called? Pyramid. That's a pyramid. Yep, those will be. That's probably my favorite day of the year on Monday. Talking about a pyramid. Can't wait. How many faces on the old pyramid? 5 faces. Edges. Is it 8? It is. And then how many vertices? Vertices? 5 vertices. Hey, everyone stop what you're doing right now. Because some of you maybe I went too fast, or maybe you didn't get one because maybe you forgot a vertice or double counted one. 1793, that was the year. 1793. Mathematician by the name of Leonard Euler. And I'm not making, this is not a story like SOHCAHTOA is Pocahontas' brother, who probably some of you still think is true. Leonard Euler, 1793. He started doing a bunch of these and he noticed a pattern. And I'm going to give you that pattern right now so you can check yourself to see if you're doing it correctly or not. He found the following. So if you ever want to check that you have the correct number of vertices, edges, and faces, here's what he found. If you take the number of faces and add it to the number of vertices, and subtract that number with the number of edges, I don't know how, I don't know why, but it doesn't matter the polyhedron, you'll always get 2 as your answer. You will always get 2. I have no idea why. 6 plus 8 minus 12. 5 plus 5 minus 8. Unbelievable. Leonard, beast. He was in probably BC math, right? Anybody know what 3 is called? That polyhedron? Not a lot of people ever know this one. You think you know, Griff?
Triangular prism.
Oh, unbelievable. Triangular prism. It's a prism, and why do I say it's triangular prism? Those are the bases, triangles. Hey, how many faces? 5? 5 faces. Edges? 9 edges. And how many vertices? Should have 6 vertices. Let's check. Ready? 5 plus 6 minus 9. I don't know. I don't even know. It blows my mind that works every time. You guys all good? Faces, edges, vertices before I go a little different topic here. We're all good? All right. Next up, cross section. Cross section. You are going to cut one of these figures we've been talking about. Vertically, horizontally, diagonally, doesn't matter. So I'm going to give you a much better looking example in a second, but everyone see the cylinder I have drawn? I've basically think of, oh, here we go. Forgot we had a cylinder in class. This is pretty good for the people watching the video too, a visual display. Okay, got your cylinder. I'm going to take a plane and cut it. Right through horizontally, I'm going to hold it up to you. What figure am I holding up to you? Let me do that again. I can't really go through it, but I go all the way through, and I hold it up to you. What am I holding up to you? What shape? A circle, right? A circle. So we would say the cross section is a circle. Now, but what if I went vertically? Went right through vertically, held it up to you. Do I have a circle in front of you now? What do you have? Rectangle, yeah. Actually, watch. Let me get that cylinder back up here. There it is, right there. Me cutting it horizontally. You want to cut it vertically? Everyone see the rectangle that's formed. Okay, that's called a cross section of a figure. It could be anything. It could be any figure. It's just not, everyone see, it's just not a circle every time. Okay, it's a circle. It's a circle that way, that way, that way. Now we're, ooh, whoa. What, arch? I don't know. But it's not the same figure every time I do a cross section. Okay? Let me do a pyramid now. I cut it horizontally. Everyone see a rectangle? What do you think if I cut it vertically? What do you think? Triangle? Oh, you're too good. You're too good. Yes. And then, you know, if I do a little diagonally, we got a little trapezoid action, huh? All right. So the cross section's different depending on how I cut it. All right. But do we have the picture of a cross section here before we answer some questions? All right. Let's see. Now I'm going to start calling on some numbers. A lot of noise and movement just for flipping over a page. Which one of these 4 has the same cross section as a sphere? Well, so everyone think of a sphere and cutting it. Will I always have the same figure as my cross section or the same shape as my cross section, or will it ever be different? Take a quick peek. Let's go to spheres. All right, right now it's a circle. Do you think it's ever going to be anything other than a circle? No, nothing, right? It's always a circle. So what am I asking for in this problem? Which one will also have a cross section of a circle? So look at my figures there and think about cutting them horizontally, vertically. Which one will also produce a circle when I cut it? Ho! Numbers, here we go. Let's start off 13. 2. You know what 2's called, anybody? Cone, yes, a cone. And if anybody doesn't believe me, just because I like doing this too, there you go. A cone. Cross section right there. What do you think if I go vertical? What am I going to form? There you go. All right, all good. Speaking of a cone, which one of these four shapes will never be a cross section of a cone? Which one of those shapes will never be a cross section of a cone? I always like to see the visual. Here you go. Here's my cone. Well, you can get rid of the triangle. We definitely get a triangle. Let me go slow. Ready? Go backwards here. Oh, I'm going to get that thing. And there we go. So which one am I never going to get on a cross section of a cone? Hey, 19. 1. Square, rectangle. Never going to get there. You all right there? Nervous? It's all good?
Yeah.
Sorry, cross sections. I know. They make people sweat. Everyone's good? Cross sections and faces, edges, vertices. That's the first part of my discussion today. All right, here's what I want to work on today. All the prisms and all the cylinders. All right, what makes a prism? Let's talk about a prism first. A prism will always have two shapes that are parallel and congruent to each other. So look at the prism I gave you guys here to the left. Can anybody tell me what the shapes are here? What's that shape here and the shape at the bottom here? Those are in what do we call those two polygons? Those are 24? Pentagon. Thank you. Those are pentagons. Those are the bases. Why are those two the bases and not maybe this rectangle here? Those are the only two, ready, that are parallel and congruent to each other. Everyone agree? Those are the only two polygons up there that are congruent and parallel. So they have to be the bases. And what would I call this? Pentagonal prism. Why pentagonal? Those are the bases. You can have rectangular. You can have triangle. We usually don't say square prism. Anybody know what we call it instead? Cube. Thank you. Thank you. Cube. Hexagonal. This will tell you the name of it. It'll tell you what shape the base is in. All right. All right. So here we go. Here's where we're going to live today. Lateral versus surface area. First of all, have we ever heard those terms before? Lateral or surface? All right. Let's start lateral area. Here's my definition. The most you're going to have to write down today. Lateral area. That's the area of a polyhedron's faces. Remember we talked faces earlier. Excluding, we are not going to count the bases. Okay, we are not going to count the bases. Go back to my pentagonal prism up here. Ready? Take off the pentagons. What's left? What's left up there? What shapes? Take off the pentagons, top and bottom. Take them off. What's left? Find the area of all of them. That's the lateral area. Got me there? You take off the bases and find the area of what's left. That is lateral area. Make sense? Everything minus the bases. Surface area, that's everything. Put the bases back on and we're good. That's the area of all the faces. All right? Surface area. Area of all the faces. Okay? Surface area is everything now. Everything. Lateral area, you can't do the bases. You got to do everything else. Questions from you guys? All right, I am going to start with question number 2 here. All right, I'm going to start with question number 2. Do you see what shape are the bases in first? That's my question. Let's identify what the bases are. The bases have to be the two shapes that are congruent and parallel to each other. Name the shapes that the bases are in for number 2. 18. Those are triangles. The bases they're the only two up here that are congruent and also parallel to each other. So those are the bases. Everybody, take them off in your mind right now. Take them off. Take them off. Because that's how we're finding, I'm going to abbreviate this LA, lateral area. Take off those two triangles. What is left over now? What is left over? 1. Here. I know. 18. What's left over? How many? 3 rectangles. That's what I want you to find the area of and add them together. Lateral area. Making sense? Take off the bases and find the area of what's left. All right? Claire said you have 3 rectangles left. What is the dimensions of the bottom rectangle? So I can multiply them. What times what for the bottom one? What about the bottom rectangle? Oh, 6? 16 times 12. Length times width. Good work. How about the rectangle on the left? This one right here. The rectangle on the left you can find, which is, what we're going to have to multiply together. 10? 9 times 16. Yeah, we're working now. Everyone's good? Plus, what about the rectangle on the right? Oh, that's 16 by, we're in trouble. Not labeled. 16 by, I need to know that. It's May 6th. It's May 6th. If at this point in the year, we don't know we need to use this, since I think we've used it literally every unit. How am I going to find that missing dimension? Come on. 7. Pythag, thank you. 9 squared plus 12 squared equals c squared. Let me know what the missing base is when you're ready. 18 on fire today. 15. And then we just crunch away in the calculator. What do you think about the units? What do you think? Should it just be inches or square inches? Square inches. Read this. What did we just find? Lateral. Say it really loud now. Area. There's my answer, right? Good. Now surface area. Put those triangles back on and tell me the full area now. So it's going to be my lateral area plus, here's how I'm just going to start off. Your 2 bases that are the same multiplied by big B, which I'm going to say is 2 times the area of the base. And now this is why last unit is so important. You already know it's 576. You told me that the base was a triangle. What from last unit, what's the area formula for a triangle? 23, area formula for a triangle. It's a right triangle. Even better, it's a right triangle. We know about the base and the height of a right triangle. So what is the base and the height here? 10?
9, and the base is 12 and the height is 9.
2 legs. Just like last unit. If it's a right triangle, the base and the height are the 2 legs. Plus 2 times 1/2 times 9 times 12. And now you are on your way, kids. $684. And I know this should be common sense, but I'm going to say it anyway. How should your surface area compare to your lateral area? It should always be greater than your lateral area, right? Surface area should always be greater than lateral area. Questions? All right, let's go back to number 1 now. Anybody know what I called number 1? What do I call this? Rectangular prism. Now for here, this is why I didn't start here. I'm not going to have you find lateral area. Here's why. What are the bases? By definition, it should be 2 shapes that are parallel and congruent to it. Would the right and the left, that's crappy, I know. Would the right and the left work? Okay, so those could be the bases. How about the top and the bottom? Could those be bases? Parallel and congruent? How about the front and the back? What's the point I'm making? How do we know what the bases are to take them off and find the lateral area? We don't. So with the rectangular prism, I'm always just going to ask for surface area only. And I got to change the notes for next year anyway. Surface area only. Okay, because again, I don't know what the bases are. They could be 3 pairs of bases in there. And depending on what you take off is going to affect your answer. So let's just do surface area. Name the dimensions of one rectangle. 18. Claire, you're on fire. Length and width of one rectangle, Claire. 3 and 3, and there's 2 of them, right? So is everyone all right if I do 2 times those 3 by 3 rectangles? Give me another length and width of another pair of rectangles. Oh, 21. 10 and 3, there's 2 of them. And what about the third pair? Also 23. Also 10 and 3. So you could go 4 by 10 by 3, or you can do another 2 10 by 3. It's up to you. All right. So surface area only for a rectangular prism. I just don't know what the heck the bases are to take off. (138 square inches). Looking good. All right, before I move on, are we okay with the concept of lateral area? Take off the bases and find out what's left over. Are we okay on surface area now? All good? Because I'm really flipping the game on you now and making it going to work next. These are prisms. Next up, cylinders. Cylinders. It would be real nice if I could just, here's the formula for lateral and surface area. What class are you in though? Honors, right? So you guys are going to figure out the formula by yourself. Or with me anyway. I'm just not going to give it to you. All right, lateral area. What's lateral area mean again? Everything but the what? Find the area of everything but, okay? Okay, they're gone. Everyone see the blue that's left here? I took the bases off. It's still a cylinder. That doesn't, right? Taking off the bases and me saying, now find the area of what's left doesn't help you guys. It's still a cylinder. So how am I going to find the area of what's left over here? Because that's the lateral area. You ready? I'm going to cut it. Watch what happens. What's this going to actually end up forming when I unravel that lateral area? What's it end up forming? A rectangle. The lateral area ends up forming a rectangle, doesn't it? Everyone see? Oh, you want it again? Sure you do. Here you go. Ooh. Everyone see the lateral area is formed a rectangle. What's the formula for a rectangle? Length times width, base times height. Don't write that down. I'm just going to go length times width. Okay? That's not the formula I want, though. What is the length and the width as far as this cylinder goes? Tidy it back up. Everyone ready? And I know it's on there already, but what's this side of this length or width of the rectangle? That's the what of the cylinder? Height. Okay, so in for L or W, I'm going to plug in height. Here's where you're going to make your money and impress people now. What about this side? Length times width. Height times what the heck is that in the cylinder? Whoa, rewind. Everyone see it? Right here, right? Right here. That's this whole side here. What do I refer to that as? Serena, let's go. Come on. What do we got? Circumference. There it is. Height times circumference. Keep going. Come on. Go back 2 units now. Circumference formula. Pi. You just found the lateral area of a cylinder. Pi d times the height. Length times width. Think of it that way if you ever forget. Length times width. Pi d times the height. Oh, you guys think you're off the hook now. What about the surface area? What about the surface area of this cylinder? Now what am I going to put back on? What am I going to put? The bases, which are what shape? And how many of them are there? You're taking the lateral area and putting back on 2 circles to it. You're taking the lateral area and adding on what? 2 circles. I know. Keep going now. Adding on 2 circles. Come on, last unit. Last unit. 2 pi r squared. Got it. There you go. You got it. Prove that all by yourself. Feeling good? All right. Ready to get this done? All right, first 2, just find the lateral area for me. So I'm going to use pi d h. This is for a cylinder. Diameter is 10. Now I really, stop, just everyone stop. Look, I get it. You know the height's 2 because it's the remaining number there. Sometimes there's going to be a lot more numbers and you got to figure out which one's the height. Here's my best definition of the height of a cylinder. It's the distance between the bases. See what I mean? The distance between the bases is where you can find the height. All right, it's just not the remaining number. It's the distance between the bases, and I'll keep saying that today. So go ahead, round to the nearest tenth. .8 square centimeters. How about 4? Whoa, whoa, easy, easy. What are you plugging in for? Not 3, but 6. Watch out for that. Wait till we get to surface area. It gets even more complex. And the height, I know the 6 is the 6 meters is the only remaining one, but do you see what I mean by it connects the bases? Distance between the bases. I'm not going to spend time here. 113.1 square meters. Good work. We're okay. Okay, surface area now, but in terms of pi. So you're going to do your pi dh, but add on pi r squared. And here's where I get worried. The left side is diameter, right side is radius. So make sure we're not plugging in the same number here. What about diameter? 2. Height, 3, connects the bases. Now be careful over here. 2 pi, what am I going radius? 1 squared. We need the calc for this. It's in terms of pi. Right? It's in terms of pi, so we shouldn't be rounding to the nearest. Ready? 6 pi for the lateral area. And then what do we got? 2 pi for the circles. I know we hit on this very briefly last unit. Can you combine those two? 6 pi and 2 pi. They both have pi's in them? Combine them. As long as they both have pi's, combine them. So this is going to be 8 pi square meters. Yep. And we're not even to the grand finale yet. All right, this cylinder. Diameter's given as 7, height of 10. But now radius should be 3.5, right? 3.5 square. $70 pi for your lateral area. Plus, oh boy, I need a little help there. What's that? Something and a half? 3.5 squared times 2? 12. 2.25? 12.25. Is it 2.5? 12.25?
When you multiply by 2, it's 24.5.
Okay, okay, oh, okay, got it. Yep, that's what I wanted. Times 2. 24.5 pi. They both have pi's. 94.5 pi square centimeters. What's up, Paul?
You just did like the whole, like, here, if you just did pi times 7 times 10 plus just the second line and then divided it by pi, you would get 94.5. You do that too.
You better have pi in your answer.
Yeah.
Because 94.5 is not the answer.
No, 94.5 and then pi.
Sure. Anything else? You ready to get to? This is how I want to end class every day, with one of these problems, where whatever polyhedrons we talked about, let's smush them together and see if we can find the area. All right. Oh, look at that figure. Look at that beautiful thing. Find the surface area. What do I have on the bottom? Rectangular prism. I think we can call it a cube, Matt. What do you say? Since all the dimensions are equal, call it a cube. And what do I have on top? Cylinder. So shouldn't this be as easy as cube plus cylinder? We're going for the weekend. Right? Cube plus cylinder, surface area, we're going for the weekend. I wish it was that easy. There's a problem. We need to revise our definition of surface area. Surface area is everything that is showing on the outside. We cannot count something that is covered up. All right? We cannot count something that's covered up. So is something covered up on the cube? Yep. Is something covered up on the cylinder? Yep. We can't count it. Whatever's showing on the outside. Everyone all good? Whatever's showing. Basically, I know this is kind of weird, but whatever you can rub your hands around, all right, or touch, okay? Yeah, okay, I know it's weird, but it gets the point across, all right? Grow up, all right, good? That's what I think about. Because nobody's touching the bottom of that cylinder if you rubbed your hands around it, all right, like a genie, all right? Good? Or wishing well. All right, I'm done anyway, I'm done. I'm done. Scrap that for next year. I better edit. Only video I edit this year, it'll be after this class. All right, get over yourselves, all right? Rubbing the figure. Get out. All right, we're good. Cube and cylinder. We ready? I cannot wait for Monday. I cannot wait for Monday. All those phones are up there. Cube, you ready? How many faces? 6, right? And they're all 5 by 5. But you're not leaving it like that, because not all 6 faces are showing, are they? Clean. What do I still need to subtract out? Does everyone okay why I can't just do 6 times 5 times 5? Because this face right here Not all of it's showing, so I don't calculate its full surface area. I have to subtract out the what that's on top of it. The circle that's there. So I need to subtract that out. So it's going to be minus pi r, which would be r 2 squared. Is everyone all right? That's how, that would be the surface area of the cube. That is everything that's showing. And then how about cylinder? Can I do pi dh? Can I do plus 2 pi r squared? Can I do 2 pi r squared in this case? That's the formula. Or no? No, I can't because one base is covered up. So instead of doing 2 pi r squared, I'm going to do just pi r squared. Is this okay? Why I can't count that? Whatever's covered up, you can't count. What's that going to be? Pi times 4 times 4, the height, plus pi times 2 squared, the radius. What's this end up being? 150 minus 4 pi? And this should end up being what, 20 pi if I do that? 16 pi plus 4 pi, 20 pi? And if you want full decimals, that's fine, just don't round them. So here's our surface area. 150 minus 4 pi, your cube, plus the cylinder, 20 pi. And I apologize for no rounding directions. Let's just go nearest 10th to finish this off. Nearest 10th. .3 square inches. This is what I need you. This is the honors level of what I need you to do this unit. Putting two figures together and finding the surface area. And understanding that I can't count figures that are covered up. Questions, comments, anything? Okay. If you want to start on page 8 right now, you can with the cross sections. It's just 5 questions that go pretty quick. And the rest is out of the textbook. Sure, Mama. Go right ahead. Next Thursday, first quiz on surface area.